In this next problem, we are asked to find the slope of the line tangent to the graph of this equation. Now, anytime you see slope of the line tangent, that should ring derivative. Slope of a tangent line is the definition of what a derivative is. So I need to begin by taking the derivative of this equation. So we're going to start by taking the derivative one piece at a time. So the derivative of this first one is going to be 2x times the derivative of x would be dx dx plus the derivative of this one, I got my 4, then derivative of y squared would be 2y times dy dx, there's my hook on, equals the derivative of 25 is 0. So now I'm going to rewrite some of this. This is 2x. This is going to be times 1, because like we learned in the last video, the hook-on factor for x's is always a 1. We don't really need it. We can just ignore it. But the hook-on factor for y's is not a 1. So then we definitely need it. So now I've got this 2x plus 8yy prime equals 0. Now I want to solve for the derivative, or solve for y prime. So I'm going to minus 2x to both sides. So I have 8y prime equals negative 2x. And then divide by everything but the y prime. So then I get y prime by itself. Now, I can simplify this. So I've got y prime equals negative x over 4y. Now, that is the equation for the derivative. I want to find the derivative at this point. So this is x, comma, y. So that means I'm still going to have y prime. I'm going to plug 3 in for x and 2 in for y. Because that's what the problem told me. X is 3, y is 2. So then I get the slope at that point is going to be negative 3/8. Now, if the question happened to ask you for the slope of the line normal to that point, normal is perpendicular, so you would take the opposite reciprocal of this, and that would be the slope of the line, of the normal line. This is slope of the tangent line, slope of the normal line is opposite reciprocal. So, there's that one. Let's do example number 3. Ooh, my surface will calm down. Let's try example number 3. We're given this equation. First off, we need to find the derivative and then evaluate at this point. So we need two things, find the derivative and evaluate. I'm going to start to go a little faster. So I'm going to take the derivative one piece at a time. So the derivative of that first piece is 3x squared. I could do my hook on of dx dx, but that's just 1, so I don't need to write it. This second one is actually a product rule. So I have x and y. Derivative of both, derivative of x is 1, derivative of y is y prime, and then I'm going to do my product rule. So x times y prime plus y times 1 plus the derivative of this one is 3y squared. I need my hook on for this one, dy dx, equals, derivative of that is 5. My hook on would just be dx dx, so I don't actually need it. Now let's start to simplify. So I have 3x squared minus 2xy prime minus 2y. I distributed that negative 2 in, plus 3y squared y prime equals 5. Now I need to solve for y prime or dy dx. Best way to do that, anything that doesn't have a y prime, I'm going to take to one side. So that one, and anything that does have a y prime, I'm going to leave it. There we go. Next, factor your y prime out of what's left. And then you can divide by everything but your y prime. And then your y prime is by itself. I got y prime equals 5 minus 3x squared plus 2y all over negative 2x plus 3y squared. Now, I'm not quite done because the second part of the problem was to evaluate at the point 1, 2. So, let me show you how to write this. That was not very good. Y prime at 1, 2. Which essentially means you're going to plug 1 in for x, plug 2 in for y, and simplify and you're done. So, I'm going to have you pause the video, try to do that part on your own, come back for the answer. Okay, you should have gotten 6/10. If you didn't, go back and check what you did with what I did, see where you went wrong. In the next video, we'll do the last 2 examples.